Hello friends, this video on NEET Current Electricity is brought to you by examfear.com. No more fear from exam. Let us now move ahead to the next topic where we will discuss EMF and terminal potential difference of a cell. Now, these two are very closely related terms but they are different. So what is EMF? EMF stands for electromotive force. But please remember that this is not a force. The name is just a misnomer. It is actually potential difference. So the potential difference between the two terminals of the cell in an open circuit. Open circuit means the circuit which is switched off, where the switch is not on. So in an open circuit there is no current flow. So open circuit means no current flow. So when there is no current flow in the circuit, at that point in time, the potential difference between the two terminals of the cell is EMF. This is generally denoted by a capital E. But what is terminal potential difference? Terminal potential difference is the potential difference between two terminals of the cell in a closed circuit when there is current flowing in the circuit. And terminal potential difference is generally denoted by a capital V. Now, why is there a difference? Now, why the potential difference between the two terminals of the cell changes in an open circuit than in a closed circuit? That's because when a current starts to flow in the circuit, there is some amount of voltage drop across the resistances. And as a result, the potential difference between the two terminals of the cell reduces. Right? So basically what happens is in a closed circuit, the terminal potential difference V is equal to E minus IR, where IR represents the voltage drop when the current passes through the cell. So here R represents the internal resistance of the cell. So looking at this, you can very clearly understand that the value of V is less than E. But this situation is true only when the cell is present in a closed circuit, and this situation is known as discharging of the cell. Why discharging? Because when a cell is connected in a circuit such that the energy of the cell is getting used up by the circuit. Now when there is a current flow in the circuit, so that current flow also needs some energy, and that energy comes from the cell. When all the energy of the cell gets used up, then we say that the cell is totally discharged. So we charge the cell again. So that's how the cells work, right? We have so many toys which work on the chargeable batteries. So when the entire charge is exhausted, we charge them again. So charging and discharging keep happening. So let's quickly see what happens during charging and discharging of a cell. So during discharging of a cell, EMF is always greater than the terminal potential difference. Why? Because what happens during discharging? So as I mentioned just now, that during discharging, the potential difference, the terminal potential difference is equal to E minus IR, where IR represents the voltage drop across the resistances. So during discharging the current flows, energy of the cell gets used up, so gradually the terminal potential difference between the two cells is reducing, right? So it has to be less than the EMF of the cell, right? But the situation is just the opposite during charging of a cell. So what happens during charging? Now during charging, the circuit is somewhat like this. You have a charger which is connected to the cell. So this is how your circuit looks like. Now let's say this is the positive end of the charger, this is the negative end of the charger. Okay, so now what happens? Now this time the current flows from the charger, because now the cell is totally exhausted. The cell doesn't have any energy. So the cell is now taking energy from the charger, and it is charging it up. Correct? So this is the circuit during the charging of a cell. Now in this case, what happens is the terminal potential difference becomes equal to EMF of the cell plus IR. So the charger provides the current which charges the cell in this case. So in this case, the direction of the current has changed. So even if E is the EMF of this cell, but this time the terminal potential difference is equal to EMF of the cell plus IR. Right? So this is the equation during discharging, and this is for charging. So now I hope that the concept of terminal potential difference and EMF is clear to you, and also what happens during charging and discharging of a cell. Thank you. Please visit examfear.com for free quality education. You can learn with a simple 4-step learning process wherein you can watch video lessons, you can ask your questions, you can refer notes, and you can take a free online test. We have content for class 6 to 12 on physics, chemistry, mathematics, and biology along with practical videos. So please subscribe to our channel for daily updates. Thank you.